Today we will learn about chapter 1, inverse trigonometric function. So this is the formula for differentiation and integration of inverse trigonometric function. So we have several trigo we have here, which is sine, cos, tangent, cotangent, secant and cosecant. So let we try to solve this equation one by one in order to solve by using the inverse trigonometric function. So the first question, we have a question which is x cubed y plus with x y cubed is equal to 2. So we need to solve by using the implicit differentiation. So first of all, we need to write down back our function here. Okay, so x cubed y plus x y cubed is equal to 2. So we have 1, 2, and 3 function. 3 different function here. So we solve one by one. So the first one for x cubed y. So x cubed. Okay, so if we can make border here. So this is your u. So u is equal to x cubed. Then your u prime become 3x squared. So this is your v, which is y. So v prime is equal to dy over dx. Okay, then for the second one, this is your u, which is equal to x. So when you find du dx or u prime is equal to 1. And then your v is equal to y cubed. That v prime is equal to 3y squared. Okay, so let we solve one by one. So the solution is u v prime. Okay, differentiation dfx dx for product rule is equal to u v prime plus with v u prime. So u for the first equation is x cubed u multiply with v prime dy over dx plus with v y u prime is 3x squared plus with the second equation here. So second equation, our u is x multiply with v prime 3y squared dy over dx plus with y cubed multiply with 1. And 2 is a constant. So when we differentiate 2, we will get 0 here. Okay, then we rearrange this equation. We move all that function have dy dx to the left hand side, and any constant or variable without dy over dx we bring to the right hand side. So we have left hand side and this one right hand side. So we draw or write down this equation by factorize our dy over dx. So the first one, our dy dx, when we factorize, what left is x cubed. And then for the second one, when we factorize this function, we have 3xy squared. So that we will get is equal to negative y cubed minus with 3x squared y. Then we only want our dy over dx here. Okay, so we move our function without dy dx to the right hand side. So when it involves multiplication at the left hand side, so when we bring to the right hand side, it will become dy. So negative y cubed minus with 3x squared y over x cubed plus with 3x y squared. So this is the answer for the first example. Let me look at the second example. So for the second example, is involve trigo function. So how to solve this equation by using the implicit differentiation? So we have 1, 2, and 3. So we have 3 different functions actually. So the first one, when we differentiate 5 cos x plus y, we do constant. This 5 is a constant, so we no need to change anything with the constant. So we just write down back the constant. Okay, cos, when we differentiate cos, we will get negative sine. See, this is x plus y, this is an angle. So we need to write down back the angle. Then we need to multiply by the differentiation of the angle. So that we differentiate u, which is x, 1. And when we differentiate y is equal to dy over dx. Then minus with differentiate exponential is we need to write down back 3e power of y and multiply with the differentiate of power. So differentiate power, we have power y here. So when we differentiate y, we will get dy over dx. Okay, then we differentiate 4x, we will get ax. Okay, so then we expand this bracket first. So when we expand, what we will get? Expand 1 by 1. Okay, so we will get negative 5 sine x plus y minus with 5 sine x plus y dy over dx minus with 3 power of y dy over dx is equal to ax. Okay, so we factorize, or we bring our dy dx to the right hand side. Okay, we bring dy dx to our right hand side. So what left after we bring dy dx to the right hand side, and the constant without dy over dx we bring to the left hand side. So negative 5 sine x plus y minus ax is equal to 5 sine x plus y dy over dx plus with 3 power of y dy over dx. Okay, so to make our equation more beautiful, we rearrange back. Okay, we factorize our dy over dx that we have here. Okay, our dy over dx we factorize because this question only one dy over dx. So first we just write down back the function at the left hand side. Negative 5 sine x plus y minus ax is equal to, when we factorize, we will get 5 sine x plus y plus with 3e power of y dy over dx. Okay, so we move the function with dy over dx to the left and this one to the right. Okay, so dy over dx multiply with 5 sine x plus y plus 3e power of y is equal to negative 5 sine x plus y minus ax. So we only want dy over dx. Okay, so what happened to our equation? We will get negative 5 sine x plus y minus ax over 5 sine x plus 1 y plus with 3e power of y. So be careful, we cannot simplify 5 sine x plus y at numerator and denominator. You just left your final answer until this. Okay, so let we move to the next example. So here we have an example of trigo and exponential. So the first one, we have 1, 2, 3. So we have 3 equations here. So we differentiate one by one. So let we differentiate y, we will get dy over dx plus with 3 is a constant, we just write down back. And then we open, we differentiate sine, we will get cos. The angle must be exactly the same with the given angle. Then multiply with the differentiation of x over 4, which is that angle. So we will get 1 over 4. Okay, close all the interval. Then we differentiate e power of 2x with tangent inverse 3x. So this is product rule. So we need to use the formula of u v. U multiply with v, and the differentiation of this is equal to u v prime plus v u prime. So our u here is e to the power of 2x multiply with tangent inverse. So if we look at the table, okay, the table multiply differentiation of tangent, we will get this, okay, which is 1 over 1 plus u square du over dx. Okay, so what we will get is, we just write down 1 over 1 plus angle square. So our angle is 3x, then we square this function, multiply with the differentiation of 3x is 3, okay, close interval, plus with v u prime. So our v is tangent inverse 3x. Okay, multiply with our v. Our v is exponential, so when we differentiate exponential, we will get e power of 2x multiply with 2. And then after we get all our steps, we need only dy over dx at the left hand side. So we simplify this function, then we will get 3e power of 2x over 1 plus 9x squared plus 2e power of 2x tangent inverse 3x minus with 3 over 4 cos 1 over x over 4. Okay, so this is our final answer. Just left your dy dx in term of this. Okay, next let me look at example 4 here. So we have trigo, okay, trigo function and also exponential function. So when we differentiate, okay, we have 1, 2, 3. Okay, so we differentiate one by one. So when we differentiate y, we will get dy over dx plus with, we differentiate 4 cos x over 2. So when we differentiate 4 cos, okay, 4 is a constant, we put outside from the bracket, then we solve for cos x over 2. So we will get sine, when we just write down back x over 2 multiply with the differentiation of x over 2 is 1 over 2, okay, is equal to, this one is u times v. So our u is e to the power of x squared multiply with the differentiation of sine inverse 2x. Okay, if you look at the formula, sine inverse, differentiation of sine inverse, we will get 1 over square root of 1 minus u square. So u here is the angle, which is u equal to 2x. Okay, so we just plug in into the formula of differentiation of sine inverse trigo. So we will get 1 over square root of 1 minus angle in bracket square. And then we multiply with the differentiation of 2x, which is 2. Okay, so we close the interval plus with v u prime. So our v is sine inverse 2x. Okay, multiply with the differentiation of exponential, then we will get e power of x squared multiply with the differentiation of x squared, we will get to x here. Okay, then we only want dy over dx at our left hand side. Other than dy over dx, we must bring to the right hand side. Okay, so what happened is dy over dx is equal to, okay, we simplify, here we get 2e power of x squared over square root of 1 minus 4x squared plus with 2x e power of x squared sine inverse 2x. Okay. You please remember 2x first is the angle, while 2x at the back is the variable. So you cannot simplify multiply. Cannot multiply. Okay, so you just left like this. Then you need to minus with the number here. 4 over 2 is 2. So 2 sine x over 2. Okay, so this is our final answer. Next, example 5. Okay, example 5 is an integration. So let we look at the table of formula for integration. What is suitable for this question? So exponential over 1 plus 4. Okay, exponential 1 over plus. Okay, it's like this. Okay, the example of this question is like this. So we need to rearrange our equation in terms of tangent inverse u here. Okay, so first of all, we have 4e power of 2x here. So this one is our u. U square is equal to 4e power of 2x or 2e power of x square is equal to u power of 2. Okay, then when we cancel 2 at the top, u will become equal to 2e power of x. Okay, then we simplify du over dx. Du over dx is equal to 2e over 2e power of x also. Okay, so we want only dx. We just rearrange dx, move to the right, and 2e power of x move to the left. Or we rearrange, we make dx as a subject, then we will get dx is equal to du. Sorry, dx is equal to du over 2e power of x. So when we integrate this function, exponential of x over 1 plus 4e power of 2x dx, then we first rearrange the equation e power of x over 1 plus u square. We substitute e with u, then we will get du over 2e power of x. Okay, so this we bring from here, from dx here, we bring to here. Okay, then from here, okay, we put the constant outside, and we simplify what we can simplify. So what left is square root 1 over 1 plus u square du. So now it seems like the formula of tangent, du over 1 plus u square. Then when we solve this, we will get tangent inverse u plus c. Okay, so the answer is 1 over 2 tangent inverse u plus c. But remember, don't forget to substitute back our u. So what is our u? Class previously, our u is equal to 2e to the power of x. Okay, and plus c. So this is our final answer for the example 5. Next, let me solve for example 6. Okay, for example 6, we have tangent at numerator. So let we put our tangent here as u. u is equal to tangent inverse x over 2. Then when we differentiate du over dx here, then we will get 2 over 4 plus with x squared. Okay, we rearrange dx move to the right, and we rearrange back this equation 4 plus x squared over 2 du. Okay, so when we solve, tangent inverse x over 2 over x squared plus 4 dx, then we will get integrate of u over x squared plus 4 multiply with 4 plus x squared over 2 du. Okay, this is we get from here. Okay, so from here we can cancel 4 plus x squared, 4 plus x squared at numerator and denominator. Then after cancel, so what left is 1 over 2 is a constant, so we can put in front. So what left is u du. So we integrate as usual, u du, we will get u squared over 2 plus c. And don't forget to substitute back our u. So 1 over 4 tangent inverse, which is our u, is x over 2. So all of these tangent inverse must be square, then plus with c. So this is the example of 6a. And then we look at example 6b here. Okay, if you look at example 6b in the bracket here, it seems like we will use what? Okay, a square minus b square. So a square minus square root of a square minus b square here is become like sine inverse u over a. Okay, so what we need to do first, let u is equal to 16x square. Okay, so our u square is equal to, we simplify this, put in bracket, then we will get 4x square. So our u is equal to 4x. And then the first one is our a. So 25 is our a. So a square is equal to 25. A is equal to 5. Okay, so from u, we will differentiate for our u here, and we will get our u is equal to du over dx is equal to 4. And we change the and rearrange, we will get our dx is equal to du over 4. And we integrate this function 1 over square root of a square minus u square dx. Then we solve, we will get dx. Okay, remember when you substitute your function with u, and dx also need to change in terms of u. So 1 over square root of a square minus u square multiply with dx is equal to du over 4. Okay, so remember the formula for trigo previously. Trigo is when we differentiate du over square root of a square minus u square, we will get sine inverse u over a. U, we need to take the value of u, and we also need to take the value of a here. Okay, so from here we put 1 over 4 is a constant in front, sine inverse u over a. So this is the basic formula. Then don't forget to substitute back your u and your a. So we will get 1 over 4 sine inverse, u is 4x over a is 5 plus with c. Okay, so this is the example for number 6. Okay, then example number 7. Evaluate the following integral. Okay, so first of all, we have a function in of square root, very large function. So it's more easy to use using completing square in order to solve this equation. So x square minus 6x plus 8. When we solve by using completing square, we will get x minus b over 2 square minus with negative 6 over 2 square plus with 8. We solve and we will get x minus 3 square minus with 1. Okay, so from here, after we completing the square, we write down back the equation by substituting our integration with completing square. So dx over x minus 3 square root of x minus 3 square minus 1. Okay, so we assume x minus 3 that we have factorized previously is our a. Okay, let me put this as our, or we didn't want to use a, we also can write down it as our u. So u, this is u. Okay, so when we replace with u, we will get integration of dx over u multiply with square root of u square minus 1. Okay, so look at table of integration or differentiation of inverse. When we differentiate du over u square root of u square minus a square, then we will get second inverse u plus c. Okay, so from here, we will solve and we will get the answer is second inverse x minus 3 plus c. Okay, next, this is example 7b. Okay, so first, we made the variable with x is u. So u square is equal to 7x square. And then the number in front, a square is equal to 2. Okay, so a is equal to square root of 2. And then du dx, when we differentiate, we will get we not differentiate, but we bring 2 to the left, we will get square root of 7x square or square root of 7x. Okay, so this is du over dx. Okay, sorry, du over dx, then we will get, this is our u. Okay, this is our u. Okay, so we want to find du over dx. Du over dx, so it will become square root of 7. Then we want dx as a subject. Then we will get du over square root of 7. Okay, so we want to replace our equation with this solution. Okay, so we just write down back the equation of dx over 2 plus 7x square. Then we will get is equal to 1 over square root of a square plus with u square multiply with du over square root of 7. Then we will solve this. We put the constant in front, 1 over square root of 7 multiplied by 1 over square root of 2 tangent inverse multiply with the angle, which is angle is u over a. U over square root of 2 plus with c. Okay, so when we expand, or no need to explain, or we just draw without bracket for tangent. So it will become 1 over square root 2. Sorry, 1 over square root 2 we have here, because we have 1 over square root 2. Okay, we simplify this, all the constant we write down in front. So 1 over square root of 7 multiplied by 1 over square root of 2 tangent inverse square root of 7 over square root of 2 plus c. So this is the answer for example 7b. And then the rest we have as exercise chapter 2, as just chapter 1, exercise 2 and 3. Number 1, 2 and 3 can try by your own.